introduce my fellow team members who trained and learned to operate and maintain this loom. In the back we have Harry Butler, and we have a pair of marks. We simply call them Mark 1 and Mark 2. We spent 3 weeks with Mr. Takeuchi from Japan, who is the world expert on this loom, and enjoyed 3 weeks of very intense training, and it was very valuable for us. The G loom, of course, is light years ahead of its time. The technology in this was so advanced for the 1920s and 30s that it's just incredible. And I'd like to show you some of the parts. First of all, the shuttle, which is the automatic change that made this loom revolutionary. The shuttle creates the weft part of the weave, W-E-F-T, and it travels right to left and left to right at 156 times a minute. When we start the loom, you'll notice it's just traveling as a blur, moving very quickly. The yarn coming toward you, toward the front, is called the warp yarn. It consists of 3,200 individual strands of yarn, and the machine is so advanced that poke-yokes are built in. That's a fail-safe device that stops the machine if something is abnormal. We still use poke-yokes out in the plant, but we now have the advantage of modern electronics, fiber optics, photo eyes, and so forth. Sakichi Toyota had to do this mechanically. When the shuttle passes across, that's called one pick, and on each pick there is a spring-loaded pin that constantly checks the diameter of the bobbin. The bobbin inside the shuttle carries about 7 minutes worth of yarn. Before this loom, as Mr. Roy mentioned, one operator could only run 3 or 4 looms. After this, 30 or 40. So much improvement in efficiency. This is the reed system that moves forward on each cycle to tighten the weave. And just behind it is the HELD, H-E-A-L-D, that consists of 2 curtains operating independently. The warp yarn passes through a loop in the 2 rows of wires hanging from each HELD curtain, and that creates a shed for the shuttle to run through. In one direction, every other strand of yarn is up as the shuttle moves. When it returns, they reverse. Every other strand is down. So you have the over-under weave effect. You'll see when the loom operates, these HELD curtains alternate, one up, one down, one up, one down. There are other fail-safes at the poke-yokes I'd like to point out. One checks the weft yarn to make sure it's present. There is a fork that moves every time the reed moves forward, and it's checking for this weft yarn. If it's not present, there is a latch, the machine automatically stops. That's the control lever. Behind the HELD system are 4 rows of stainless steel droppers. Again, that is to stop the machine if something's abnormal. If only one of those 3,200 strands of yarn should break, those strips will fall, and it hits a very sensitive rod that triggers leakage and again stops the machine. So very, very, very efficient. The machine, of course, is powered. Everything on the machine is powered by one source. Currently, we have an electric motor with a modern control box that allows us to meet safety standards today and lock out the power. Originally, the loom was powered via a belt driving the main pulley going overhead in the mill to a large shaft powered by a single source, either steam or water, and many looms could be lined up in a row to make that happen. The shuttle itself is very innovative in the way that it's loaded. Mr. Toyota figured out a means of improving the shuttle loading. Originally, the operator would hold the shuttle in one hand, the yarn in the other, and The object is to get the yarn out of this hole. Standard practice in the 1920s was to use one of two methods. Hold a fork in your teeth and pull the yarn out, or many operators chose to simply place their mouth on the shuttle and draw the yarn out. Maybe okay for first shift, not so good for second shift. So Sakichi figured out if he used a groove system and an opposing hole at the right angle and used recoil, he could snap the yarn and make it appear before your very eyes on the other side. So it saved a lot of health issues, was much faster than the old method. The operator could come to the trough where the empty shuttles are kicked out and pick up the empty shuttles, load them just like I did with the machine running, drop the shuttle in the tin shuttle chamber and the magazine and wrap around the tin and you're good to go. This tin shuttle magazine has a system, a slide system that allows the bottom shuttle to kick in when the empty shuttle is kicked out, and the machine never misses a beat and there is no flaw in the material. That eliminates muna, or waste in Japanese. Before that was available, the machine would continue to run, and without yarn, you'd have a run similar to what we see in nylon today. So very, very important. When the shuttle, when the bobbin in the shuttle reaches a point where that spring-loaded pin detects this groove, that tells the machine that the shuttle is near empty, and that's what triggers it to kick out. I'd like to run the machine for you. I do ask to go one step beyond the plexi because safety does insist that everyone stay around front. It will be a little noisy, I'll warn you, but we won't run it too long. Please watch these areas. You'll see the shuttle has a blur here, a blur here. You'll see the fork operating, checking for the wet yarn. You'll see the spring-loaded rod checking for the diameter of the bobbin. The reed will move forward, and the held system will work up and down. And with any luck, we should see a shuttle change as well. I'd also like to, in just a few minutes, demonstrate how the droppers work on the back, so we can show you the pokey-okey and how it operates. All right, if you're ready, we will start it up. How's that for 1924 technology? When that occurs, if the operator should come up, the machine is down, they would check to see where the issue is. You can look underneath the back and see what dropper is down, and look on either side to find the broken yarn. At that point, you use repair yarn. This is not decoration, this is here for a reason. That is warp yarn that we use weaver's knots to tie a repair. The weaver's knot is so small that it's virtually invisible whenever the repair is made, and the operator will tie one in the front, pull through the dropper, and tie one in the back, and put tension on that yarn, and it will weave itself back into place, and is, again, virtually invisible. This piece of cord is an enlarged means of showing you the difference. The top one is a weaver's knot. The bottom knot is an overhand knot like we use to tie our shoes. As you can see, the weaver's knot is much smaller. It's also stronger than the material. So It's rather difficult to learn to tie. Mr. Takeuchi, our instructor, used repetitions to teach us. We tied many hundreds of knots, right guys? Until we were fairly good at it, and he was certain that we would be able to handle yarn breakage, and it's been very good training. We thank you for your time, and we're very happy to be able to share this with you.
Thanks,
And now we'll go on to Funo.
Okay. Well, thank you, Larry. And I really appreciate everyone taking time to be here with us today. My name is Norm Bufuno, and I'm the president of Team MI. We are certainly very honored and very excited to have this important part of Toyota history right here in southwestern Indiana. Many people would not expect to see a loom right here. They expect to see an automobile. But the principles that our founding father established in the spirit of challenge, in the spirit of innovation to bring a machine like this into the marketplace that eventually sell the patent rights that form the company that we know today as Toyota is very exciting. We have an opportunity to use this type of equipment to teach our team members these fundamental aspects of our business. What you saw a minute ago with Larry, the demonstrating of one piece of yarn that would fail. If there was no detection of a failed piece of yarn, basically the entire canvas would be ruined until somebody noticed there would be a streak of a defective yarn missing. And we wanted to, Sakichi Toyota wanted to find out, is there a way to detect that automatically? We use that same type of detection in building every one of our vehicles. If there's a problem, our line stops. We address it, resolve it, and move forward. And so these kind of very basic aspects and very fundamental aspects to our business are very transferable. I would also like to thank both Larry for the explanation today, for all of our maintenance team for the great job of getting the machine up and going through your extensive training, and also for Kazoe on the perspective and the history of this important machine and what it means to us. We're certainly very honored. The last comment that I'll make is on a completely different subject. I would also, since all of you are here today, like to take a minute to thank all of our customers, because it means a lot to us. People that are buying Highlanders, people that are buying Siennas. And if July is any indication of what they think of our products, we had an outstanding one. Year-over-year improvements. With the Highlander, almost 28%. Sienna up again year-over-year. But what it means to us is the confidence and the safety and the reliability and dependability of our products. But also what it does is it works magically in the plant. Because we are hiring people. This month, we brought on 30 new team members as part of our organization. We're very proud of that. Since June, when we went back to straight time capacity, we've brought on another 100 variable workforce team members here as part of our team. But none of that happens without great sales from customers. So I'd like to take this time to thank all of them on behalf of everyone here at Team MI. And now what I'd like to do is open it up for any questions you might have about anything you saw or anything else in our visitor center. And we'd also like to give you an opportunity to walk around if you have any specific questions with our team members from those areas to answer any questions for you as well. So does anybody have any questions?
If you want to show the piece of fabric, if you want to show them what it actually looks like, feels like,
Okay.
Larry will get that for you.
This is 100% cotton and 460 thread count, so I'm told it's pretty good stuff. It can be used as is or dyed. And if anyone would like to check it out, please.
What's the thread count?
460.
460.